Welcome to Fuzzy Mathematics, the Basics. This is the first lecture, Lecture 1, Introduction. Let's start with the concept of fuzzy sets. What is a fuzzy set? Roughly speaking, a fuzzy set is a set without sharply defined boundaries. What is a set? A set is an unordered collection of distinct objects. The objects in a set are called elements or members of the set. The concept of set plays a fundamental role in mathematics, and set theory has connections with almost all fields of contemporary mathematics. Before we introduce the definition of fuzzy sets, let's talk a bit of set theory, classical set theory. Of course, when we talk about sets, we should have a universal set of discourse. A universal set, also called a universe, is the set of the possible elements considered in a particular context. Let X be the universal set, and let A be a set. We use this notation to denote X is an element of set A, and we use this notation to denote X is not an element of set A. Usually we use capital letters to denote the sets, and we use lowercase letters to denote the elements of the sets. For all elements in the universal set, either X is in set A or X is not in set A. Sets can be represented graphically using Venn diagrams, named after the mathematician John Venn. In Venn diagrams, the universal set, which contains all the objects under consideration, is represented by a rectangle. Inside the rectangle, circles or other geometrical figures are used to represent sets. This is the universal set, and this is set A. For each element, either X belongs to set A or X does not belong to set A, excluding the middle. In classical set theory, it must be either this or that. There is nothing in between. In other words, for each element, either it has a full membership of set A or it has non-membership of set A. It is not allowed that an element has partial membership in the classical set theory. A set in the classical set theory has a sharp, crisp boundary. There exists a clear distinction between membership and non-membership. However, more often than not, the collections of objects encountered in the real world do not have clear criteria of membership. For example, old people. Old people are the collection of people who are old. In the classical set theory, there exists a crisp boundary to indicate whether or not a person is in this set. Let's say 50. If you are 49 years old, you are not old. You don't belong to the set old people. And if you are 50 years old, oh, you are old. You belong to the set old people. I don't like that. That's not the way human brain works. Am I old? I am old, but not 100%. I am old to some extent, maybe 10% or 20%. Don't be too harsh. My membership of old people is neither 100% nor 0%. It is 0.1 or 0.2 or something like that. The graph for old should look like this, right? Yes. This function is the so-called membership function. Using this function, we can determine the degree of membership of each age in this set, where 1 means 100% membership, full membership. 0 means non-membership. 0.5 means 50% membership, and so forth. Old people is not a set in the classical set theory. The boundary of this set is not well defined. It's ambiguous, it's fuzzy. Young people, old people, hot weather, cold weather, they don't have clear criteria of membership. They are not the sets in the classical set theory. They are fuzzy sets. Intuitively, a fuzzy set is a set with fuzzy boundary, and the corresponding set theory is called fuzzy set theory. To avoid confusion, the sets with crisp boundaries are called crisp sets, classical sets, ordinary sets, or just sets. That's the end of this lecture. Next time, we will introduce the definition of fuzzy sets. Thank you.